All right, so now that we've talked about Bragg's law, let's work a quick example to get a feel for the numbers and the orders of magnitude involved. All right, so this is going to be the question on your quiz for this module. So I've given you Bragg's law. I've repeated it here so you don't have to go back into the previous slides. And what I want you to do is calculate the angle at which X-ray radiation with a wavelength of 0.1790 nanometers will constructively interfere with the BCC iron 220 plane, and then I've given you that interplanar spacing. So see if you can calculate the angle and then come back and we will go over those results. All right, so let's go ahead and look at this. So this is just a fairly straightforward question, but I want you to sort of see the order of these values and so forth. So we're looking for the angle, and we're given the wavelength, and we want constructive interference, aka diffraction. And so, and that's going to happen in BCC iron, the 220 plane. And so I'm giving you the D spacing. So let's go ahead to the next slide where I've got the answer worked out. All right, so again, N is always going to be 1 for us. So I'm going to go ahead and do that. So this N equal 1. And then I'm going to rearrange, and I want to solve for the angle. And we said that theta is the angle, right? So if I rearrange this, solve for sine theta, that would be N lambda over 2D HKL, which is what I have down here. And then it's a matter of plugging things in, right? Lambda here is my wavelength of the X-ray radiation, and then the D spacing, which was given to us. And so if we put that in, as we do here, you'll see that we have nanometers over nanometers, so they cancel out, and we get 0.8835, and that's the sine of theta. So if we take the sine inverse to solve for theta itself, we get 1.08 radians, or 62.1 degrees. So this is one of those things where when you're calculating this, the only challenge is when you calculate this, make sure that you know whether your calculator is giving you radians or degrees. So that's a just good check to make. One other thing though, and we're going to talk about this in the next module, is typically data when you talk about X-ray diffraction will actually be reported not in theta as the angle, but actually 2 theta. And we'll see why this is in the next section, but 2 theta, then if we wanted to calculate that, would just be multiplied by 2, so 124.1 degrees. All right, so in the next module, we'll see why this is the case.